All right, so if you recall before break, we had started a new unit called Populations and Resources, and we were focusing on a population of organisms called jellies. So an organism is any one living thing. All right, let's close our phone books. We don't need them right now. Any one living thing, and then those organisms that live together in the same area at the same time, those are called a population. So all of the jellies living in Glacier Sea are a population, and then they interact with all of the other living and non-living things in Glacier Sea to create an ecosystem. So that's a few of our vocabulary words for the chapter so far. The main question that we're trying to answer in this unit is what is causing the population of jellies in Glacier Sea to increase dramatically over the last 10 years. Populations are always going up and down, but it's those dramatic changes that scientists are most interested in. So chapter 1, our focus was what is causing the size of the moon jelly population in Glacier Sea to increase. And our first key concept, my clicker's not working, is this idea that organisms are always being born and always dying. So we know that populations do stay stable, but that doesn't mean that nothing is happening. So births and deaths happen in all populations. So in Glacier Sea, the moon jellies have been observed being born. So there's new baby moon jellies all the time. And there's also moon jellies dying when they're eaten by predators or when they're sick or when they're old. But they're always being born and they're always dying. And that's true for all populations. So if that's true, then the number of births has to equal the number of deaths in order for a population to be what we call stable. Stability means that there's very little change. Okay, so if the births equal the deaths, the population will be stable. When it's stable, that doesn't mean that there's no births and no deaths. It just means that they're equal. The last key concept that we learned before break was if there are more births than deaths, then the population will go up. So if births are greater than deaths, population goes up. If births are less than deaths, then the population will go down. Okay, so that's the two main ideas for key concept number 4. So those are the key concepts that we learned before break. We are now at the end of chapter 1, so you should be able to answer the chapter 1 question using your key concepts. So if I was to ask you to answer this question, what caused the size of the moon jelly population in Glacier Sea to increase, you should be able to answer that using the key concepts that I just went over. An example answer would be, there are always births and deaths happening in the jelly population. That's our first key concept. If the population increased, because that's what they're telling us, it means that there are more births than deaths. That's our fourth key concept. Then you want to think about why that could have happened. So there could be more births than deaths because the births increased, right? That's a simple way to think about it. There's just more being born, or there's less dying. Okay, so think about it in both ways. Just because births are greater than deaths doesn't mean that there's always more being born. There could be, but there could be the same number being born, but less dying, and that would make more births than deaths. Okay, and we're going to talk about that more today at the end of our lesson. Any questions on the quick review of chapter 1? All right, so remember, when you are at home and you log in, we have our new Google Classroom. You're only going to see most times the number 2 for that day. There is a number 1. The number 1 is what's most important because it's going to teach you what you need to do for the day. If all you do is try to open up and complete number 2, you're not going to do a very good job, okay? So I do not have, you want to go to classwork and then you want to go to the week. I do not have Nearpods, okay? I have slides, and then after first period, there's a video. and you get to choose whether you want to do slides or watch the video. So see, there'll be 2 posted for every day. In class, you are welcome to open up the slides and follow along if you would like. If you just want to pay attention to what's on the smartboard, you're welcome to do that as well. So if you would like to open up the slides, you're welcome to do that now. All right, so this is the evidence card that we saw before break, right? Every year between 1980 and 2010, that's 30 years, ecologists counted the moon jellies in Glacier Sea. The jellies were counted in 8 different locations throughout Glacier Sea. And what did we conclude about this graph? What does this graph tell us about the population of moon jellies? What's happened over those 30 years? Nathan, give me one piece of it.
It's been equal for a while.
What's a better word than equal? What are vocab words?
There's been the same amount of births and deaths.
Yes, which makes the population
Stay the same.
Stable, right? So stable. So we've had a stable population from 1980 to 2000. So for 20 years, the births equaled the deaths. About. There's a little bit of fluctuation, but for the most part, it was stable. So births equal deaths. What happened from 2000 to 2010? Brody?
It dramatically changed.
Right, it dramatically changed. And did it go up or down?
Up.
It went up. So what would have made that happen? What would have to be going on with births and deaths in order for the population to go up, Brody?
More births than deaths.
Right, so the births had to be greater than the deaths. Very good. So on the graph, as we just talked about, we can see that the jelly population was stable before the year 2000. So here's our stable in the blue, and then it started to increase. Next, you're going to create a model showing why you think this change happened. You're going to use this modeling tool sheet to show your ideas about why population change size in an ecosystem. To make their thinking clear, scientists often use models to show their ideas about how something works. On your model, so this is what yours is going to look like, the top circle here is going to represent when the moon jelly population was stable. So what about births and deaths, guys? If it's stable, the births and deaths will be equal, right? They'll be even. So you want to make sure on the top part, your births and deaths are equal. Then on the bottom circle, the jelly population was increasing. So births need to be what? Greater than or less than deaths? If our population is going up, greater than, right? If you're zoning out, you got to zone in here. Each box on the sheet represents an organism in the population. So when you're looking at your circles, each one of these boxes is an organism. Think of it as a jelly. So we got 6 jellies. You're going to use a crossed out box to show a death and a box with a B to represent a birth. This model initially shows just 6 moon jellies in the population. Of course, there are many, many more moon jellies, but in this simplified model, you will use small numbers to show the basic ideas about how population changes size. So let's look at an example of how you can show the births and deaths in a stable population. We need to figure out how many births and deaths to show for the stable population. There are 6 moon jellies to start with. If we want to show the same number of births and deaths, then you would need your births and deaths, or you would need to have the same amount of births and deaths. So you have 2 crossed out, that means 2 died, and you added 2. Notice you didn't put them over the current jellies. These are people, not people, these are jellies. These are organisms. So you don't want to put the B on top of it. But you do want to cross one out because that means it's dying. It's going away, right? So you have 2 deaths, 2 births. You still end up with 6 jellies. Remember, populations always have births and deaths. So you can't just leave it and say, look, there's 6, it's stable. Always have births, always have deaths. So you have to show some dying and some being born. Okay? If you wanted to show more births than deaths, then you could cross out one more box. of course, then the population would be decreasing, right? It wouldn't be stable. If you wanted to show more births than deaths, then you could add one more box with a B. So now you have 7 instead of 6. So that would show an increase. It's not important exactly how many births and deaths you draw. Okay, so you don't need 9,000. I don't recommend you do 9,000. I recommend you keep it simple. But it is important to show the number of births, how the number of births compares with the number of deaths when the population is stable or changing. All right, so we went over our key concepts today already. On this model, you're being graded on your understanding of key concepts 1, 3, and 4. So you want to make sure that your model shows that organisms are always being born and dying. You want to make sure that it shows that when it's stable, you have the same number of births and deaths, and that when it increases, you have more births than deaths. I already went over our vocabulary words for today. For the chapter, the only one I didn't talk about was change. We should all know what change means. It means when things are different. So let's now go to Google Classroom then and open up number 2 for today. So that's what you should be doing when you are at home. You should be going through those slides and opening up the number 2 when it tells you to, not just automatically opening it up. And then my slide says to complete the model to show how births and deaths in a population affect its size. Come back here when you finish. When I get to Google Classroom, the directions say to complete the model to show how the births and deaths in a population affect its size. Both the slides and video contain detailed directions for completing. So if you're at home, you could use the video or the slides if you had skipped them. Once you have it open, this is what you should see. So, modeling births and deaths in the moon jelly population. That's the same graph that we have been looking at. You have been investigating the question, how do births and deaths in a population affect its size? Use the modeling tool activity, births and deaths in the moon jelly population, on the next slides to show your thinking about this question. Follow the instructions on the next slide. Your goal is to show the births and deaths in the moon jelly population when it was stable and when it was increasing. You're going to use the boxes with the B to show the births and the X to show the deaths. And if you need to, you can annotate your model with text boxes as needed to explain your ideas. There's more than one way to create the model. Remember, it's not exactly important how many births and deaths you show, but that comparison between births and deaths. All right, so here's our model. We have our stable population on top. What has to happen during the stable population? Olivia, tell me about births and deaths. They have to be equal. Very good. It is up to you how many you want to do. So down here, you have X's and you have B's. These are unlimited number of boxes. So all you have to do is click on it. And when you get your little 4 arrows, you can then drag your X. Nope, I didn't drag it very well. I made it too big. So I will just undo that. I will click on it again. Make sure I have my crosshairs. And then you want to put your X over one of the current boxes to show that that jelly died. So do that for as many deaths as you would like to have. And then you want to drag and drop your B's. The B's do not go over current boxes. Those are jellies that already exist. When you're adding B's, you're adding new jellies. Addison, is my model correct? How come? Right, I have more births than deaths. So that is not stable. Right now I have 1, 2, 3, 4, 5, 6, 7 jellies. And I started with 6 jellies. So that's not stable. So I would need to delete one of my jellies to make that stable. So now I want you to do the bottom one, the increasing. So you got 2 deaths. So how many births do you need? Oh, you got rid of. Okay, do they go over current boxes?
No.
No. So put it below them, just like you see up on my screen where my B is. Good. So now do you still have 6 jellies?
Yep.
Very good. So now you want to increase the number of jellies you have. So once you finish your bottom one, you should have more than 6 jellies, more than 6 boxes. All right, so you don't want to put these over current boxes because those are jellies that already exist, right? You want to put them below, and then I'll be done. Sure, return it. Very good, you can turn it in. All right, so you should make sure to turn that in when you finish. And then my slides told me to go back to here when I was done. So here are some things that you should have noticed when completing your model. When the jelly population was stable, the number of births had to equal the number of deaths. It didn't matter how many you had as long as the births and the deaths were equal. I did 1 and 1. You could have done 3 and 3. You could have done 6 and 6. Okay, as many as you want as long as they were equal. When the jelly population was increasing, there had to be more births than deaths. Remember, the births do not go over current jellies. Those boxes are jellies, and you can't put new jellies over old jellies, okay? And then you may have modeled an increase to births or a decrease to deaths after 2000. So what that means, I'll go back to my model. Up here, I have 1 and 1. To make my moon jelly population increase, I could have either had less death, so got rid of 1, but that wouldn't work for me because you always have to have births and deaths, right? Or I could have added a B to make more births. So you could have less deaths than you had up here, or you could have had more births. Most of you did more births, okay? And we'll talk more about that in just a second here. All right, that puts us here. So we have evidence that for the population to increase, there had to be more births than deaths. This can happen because there's an increase in births, a decrease in deaths, or both. This is the part that I think gets a little bit confusing because when we say more births than deaths, people automatically think more jellies being born, right? More jellies being born, that would make more births. That is true. But if you have 5 births and 5 deaths, to have more births, you could have less jellies dying. So less dying, but the birth stays the same. So that's the idea that a decrease in deaths also causes more births. So here we have our 2 claims then for the end of chapter 1. What could have caused the size of the moon jelly population to increase? The population could increase because the births went up. So here we have stable, right? 2 births, 2 deaths. But after 2000, we now have 3 births. So we have more being born. Or the deaths could have went down. So again, we have stable, but then after 2000, we still have 2 births, but we have less deaths. So we only have 1 dying. This is still a case of an increase, or not an increase, or where the births are greater than the deaths. 2 is bigger than 1. You do not always have to have more being born like you see up here. But this is the idea of what most people did, okay, was this top one. But we don't know which is happening in Glacier C. So that's the idea of the second chapter, is to figure out, do we have more being born or do we have less dying? So we have to gather more evidence to figure out whether the moon jelly population increase was caused by more births or fewer deaths since the year 2000. All right, that is the end of lesson 2.2. I would like you all to go to your grades.